Although you might not realize it, everything we do involves physics. There's one device in particular that just about everyone uses every single day without giving a second thought about the complex equations and concepts behind it, the eyeball.
We decided to learn more about eyeballs and the science that goes into studying and correcting them. We went to Rockland eye physicians and surgeons and learned what goes into working in this field.
First, we found out how the lens of the eye works and what happens when it doesn't function properly.
For you to see things properly, the way that your eye refracts light, the rays of light have to meet at the very back of your eyeball.
If somebody is nearsighted, the light hits the lens of the eye, but then it meets right about here. It doesn't really meet at the back.
In a far-sighted eyeball, the lens focuses light at a point behind the back of the eyeball instead of at the back of the eyeball.
With a nearsighted eye, a diverging lens is used to bend the light so that it can meet at the back of the eye instead of towards the center.
For a far-sighted eyeball, a converging lens is used, so it forms the image at the back of the eyeball instead of behind it. The autorefractor sends a beam of light into your eye, which then reflects back. The autorefractor measures the difference of how much the light was bent from what it got back to what it actually sent in the first place, and using that determines the curvature of your eye.
So if you look over here, you can see there's his eye, and the machine is taking the measurements automatically. There's one, and then you go over to his other eye, and then you put it in there. And
Oh wow, it's a balloon.
Oh, that's so cool. You're lining
I'll call it balloony too.
Is your eye okay?
don't move. Oh yeah, it's nearsighted. Look at that.
A little bit.
Yeah. When you print this, so what this did. Yeah, your right eye is fine. Your left eye is nearsighted.
You guys see?
Almost a -1.
Yeah.
So that's probably pretty blurry. And there you are.
The eyeball.
And there.
See
Now
the
don't
blinks.
blink. Keep it open. There you go. And on the other side,
It's freaky.
open wide.
And that's what it looks like for yours too.
Don't blink.
Look at the blinking.
Hold still.
It's like this, but
Yeah, I know.
everything comes down.
Yeah, she's got almost perfect eyes.
Not really.
Yeah.
I can read it with this.
But without it.
Without,
Really?
no.
Yeah.
There's like no different. This actually makes it worse on the
Makes
right
it
eye.
worse.
Yeah.
it should
It
make
probably
Yeah.
would.
Yeah, it makes it worse on the right eye,
Wait,
but
you can see
no,
better with it
I
on
can
the
see
left
better with the left eye. It is better. I can't read that, but with the left eye, it's like yeah, I am better. Yeah, I can read that. Yeah.
Here.
So
I'll adjust them.
Captions. They're gonna have text on screen.
There.
Liam gets a new pair of glasses.
There, it looks great.
Yeah, that's A glass.
Hey.
That's A glass.
Is this the new Google Glass model?
Yeah.
Yeah, yeah.
It would make more sense.
How is it, Liam?
I like it.
Doesn't it look better now?
In order to save space, the office uses mirrors to simulate being 20 feet away. Because the setup is a bit complicated, we're going to explain it using props.
The image comes out of a projector and is then projected onto a mirror. The mirror reflects the image onto a screen, and the patient looks at the screen's reflection in another mirror.
I'm standing 20 feet away from Jesse, who's holding up an eye chart. The top line is labeled 20, meaning that a person with normal eyesight can see that from 20 feet away. If you can see that also, then that means you also are 20, so that makes up 20/20 vision. You can see something at 20 feet away that someone with normal vision can see from 20 feet away. The line below that is smaller and is labeled 15. That means that the person with normal eyesight can see that from 15 feet away. If you can see that from here at 20 feet away, then you have better eyesight than normal, in this case 20/15, because you can see something at 20 feet away that a person with normal eyesight can only see from 15 feet away. To become an ophthalmologist, there is some rigorous education required. You need to fully complete medical school, as well as 3 to 8 years of internship and residency. Also, state licensure is required.